So we're looking at question 5 now, and question 5 is asking us, what is question 5 asking us? If f of x is equal to this guy here, ln of x squared plus 2x minus 1, then f double prime, that means second derivative of x is equal to which one of these? So what they're asking us to do basically is differentiate this once and then differentiate it the next time. Because of this double prime, it's asking us to find the second derivative. So what I will do is basically differentiate this guy, So f prime of x would be what? The derivative of ln is 1 on x, so, or 1 on whatever in the brackets. So my answer would be 1 on whatever in the brackets minus 1, right? But you have to remember to multiply by the derivative of this, right? That is very key, which would be 2x plus 2. So your first derivative is simply 2x plus 2 on x squared plus 2x minus 1. But we have to find the second derivative. That is really what we're going towards. The second derivative, if you look at this, two functions of x dividing by each other. So I would think immediately to use the quotient rule here. So what do we do? Let's let u be equal to 2x plus 2, v be equal to x squared plus 2x minus 1. du on dx is equal to 2. dv on dx is equal to 2x plus 2. Plus 2, just 2, right? So now we just have to remember that quotient rule, right? You all should remember it. It's v by du on dx minus u by dv on dx all on v squared. Yeah. So we could have this guy will multiply by this, right? So you'll get 2 by x squared plus 2x minus 1 minus this by this, which is basically the same two terms, so we could square them. I'm thinking we could square these two one time, all on what? V squared, this squared, which should be x squared plus 2x minus 1 all squared. Does this look like anything here? That's the question. Kinda does. If we look at D and this here, kinda does. Right? Those two things are the same. So we good enough. These are answered there for question 5. Now let's look at question 6. They are saying if f of x comma y, there's a function in terms of x and y, is such that the first partial derivative with respect to x is this, and then the first partial derivative with respect to y is equal to this. Which of the following are true? So they want us to find which one of these is f of x comma y. Right, that's basically what they want us to do. So what we need to do is find the first derivative of this with respect to x and see if it gives us this. That is what we need to do. We have to try each one of them, right? Whichever one gives us it, we could try. We could see what is the scene, what's going to happen. So let's try that first one, a, right, and see what will happen. If you differentiate this with respect to x, what will you get? Y is a constant, x is considered the variable here. So you'll get e to the y cos of x plus y. Right? So this would be a del f on del x. But this is not the same as this. So that's wrong. Right? So this could never be f of x comma y. Right? So yeah, that is a no-no. Right? So let's look at part B and see if that might be it. What is going on with part B? If I wouldn't differentiate with respect to y this either, because once one isn't working, the other wouldn't work, right? Once we don't get the correct thing for the first partial derivative with respect to x, I wouldn't go on to y. This one here, what would happen here? Differentiate with respect to x will give us what? E to the y. You would get negative sine of x plus y, plus e to the y cos of x plus y. But that will look nothing like this. If this is del f on del x, right, of this here. So nah, that don't look like it either. So I wouldn't go with B. So we could cancel off A and B one time. So let's see if it's C. We have C and D to check. It's looking like if it might be C, guys. So if we have C, if this is f of x comma y, and we differentiate it with respect to x, you would get e to the y negative sine of x plus y. Yeah, this looking kind of like this. It's just the negative sign. We had to carry it in front here, so it would look more like it. So that part good. I would then proceed to look at the second part, which is just to check to see if this del f on del y would give me this, just to confirm it. But I think it would, right? So this would be a function of y by a function of y. So you use the product rule. So it would be e to the y by what? The differential of e to the y would be e to the y multiplied by cos of x plus y. And then the differential of this by this would give us negative e to the y sine of x plus y. Right? And then we could actually factorize out the e to the y. You'll get cos of x plus y minus sine of x plus y, right? Which is basically what you have here. Pretty straightforward, right, guys? So what they're asking us really in this question is to find what is the f of x comma y that would give these two guys, right? So that's why you have to actually test each one and see if it will give it. So that's basically it. So my answer here would be C. Yeah, C is our answer there, because this is what we will get. You would get the two first derivatives that they're looking for, right? You would get this from C and you would get this from C, and that's basically it, guys. So with that said, I hope you all understood the solutions to question 5 and 6, and I will see you in the next video.